one of the people who we're going to be asking you to rate, and I'm sure it's going to be fabulous, is the wonderful KT Gamanji, who is coming forth to speak to us now about reverse engineering, cloud native, interoperability, and community. Give her a really big round of applause. She's got a slight cold, and she deserves your love. Do it now. Thank you.
Hello everyone, my name is Katie Gamanji and currently I am a senior field engineer at Apple. I have joined Apple 2 years ago and as part of this role I am bringing Kubernetes and cloud native expertise to different teams and products within Apple. As well, I have been elected as one of the TOC or Technical Oversight Committee member for the CNCF or Cloud Native Computing Foundation. As part of this role, I am joining 10 other champions within the industry, and we try to provide a technical vision for the CNCF landscape. I have many other roles in the community. However, I would like to mention that I am the creator of the Cloud Native Fundamentals course, which is completely free and you can find on Udacity. And as well, I am the recipient of 2 awards, one of them being the Next Generation Leader from the Women in IT Awards and Tech Women 100 within the UK. Today, however, I would like to reverse engineer cloud native and more specifically look into interoperability and community. And to do so, first of all, I would like to look at the emergence of interfaces. Here I'm going to focus on the interoperability, which is the principle, the base principle that created the vast cloud native landscape that we have now. I'm going to introduce the interfaces for networking and runtime, service mesh storage, and many more. Next, I'm going to focus on how we can build a sustainable community. Now, technology is the gravitational point for our landscape. However, none of it would be possible without a community around it. As such, here I'm going to focus on how we can create a safe space for the next generation of cloud native practitioners to operate in. And lastly, I would like to leave you with a perspective of how cloud native influenced vendors, end users, and the overall community. Now, before I move forward, just a show of hands, how many of you are familiar with Kubernetes? Oh, that's good. Okay. So this is going to be a very good recap talk for you all. Now, before I move forward, I would like to take a look at the industry 15 years ago. And more specifically, I would like to look at the containers. Now, to run successfully a containers, we require 2 primitives, C groups and namespaces. The C groups pretty much impose the limits on our container, such as how much CPU and memory we can consume. Namespaces, on the other side, impose what process actually can see, such as different processes, networking, file system, mounts, and so forth. However, these 2 primitives have been in the Linux kernel since 2008. And then you have a question. Why containers became popular only in the recent year? The short answer is that the technology became the competitive edge for any organization out there. As an organization, you want to deliver value to your customers as quick as possible. And for that, you had to solve 3 main challenges: application complexity, fast deployments, and environment uniformity. Now, if you look into the application complexity, this refers to the fact that we have a microservice-oriented architecture, where we have myriads of microservices creating one product. However, while we introduce simplicity of development, we still need to deal with scale and effectively deploy to production. Next, we have fast deployments. This is an imperative nowadays. The faster you deploy, the more of a competitive edge you're going to have in regards to your competitors. And the last thing is environment uniformity. And this challenge refers to the fact on how we can minimize the delta between the local environment and production. Now, all of these questions were solved by containers. At the beginning, Docker was a very good tool to popularize the usage of containers. However, we still had one big challenge: how we can manage thousands of containers efficiently. And this is where we had the container orchestrators enter into the picture. Now, if you look 9 years ago, the container orchestrator framework space was very heavily diversified. We had tools such as Docker Swarm, Apache Mesos, CoreOS Fleet, Kubernetes, and all of them provided a viable solution to run containers at scale. However, Kubernetes is the lead in defining the principles of how to run these containerized workloads. Nowadays, Kubernetes is known for its portability and adaptability, but more importantly, for its approach towards declarative configuration and automation. And we can see this in numbers as well. Based on the VMware Tans report, State of Kubernetes, which was released less than a month ago, 98% of their organizations see a clear operational benefit of adopting Kubernetes. The first one being a better resource utilization for your CPU and memory, and the second one being an eased application management, especially throughout the upgrade process. Another metric that I found quite curious is that 76% of the organization pursue a multi-cloud strategy. Now, what it actually means is that organizations want to have their availability at all times, and to ensure that, they want to avoid vendor lock-in and have their platform everywhere. And lastly, a very interesting metric is that 92% of the organizations are either deploying or using service mesh in production. Now, this is a very important metric because it showcases that we have a shift from day one operations to day two operations. Service mesh is a very complex layer that we need to take care of within the cluster. And seeing that most of the organizations use it in production is a very good sign of the maturity within our landscape. And this growing community around Kubernetes has been extremely beneficial for it, because over time, multiple tools were built around it to extend its functionalities. And this created what today we know as the cloud-native landscape, which resides under the CNCF umbrella. This is the landscape that we, the TOC, provide a technical vision for, and we work with the projects and ensure that they will reach a maturity level. Now, currently within the CNCF, we have 154 projects, which are spread across 3 different levels of maturity. We have sandbox, incubation, and graduation. Sandbox projects refers to these greenfield ideas that solve a problem for a very niche industry or domain. They still need to get that momentum. Next, we're going to have incubating projects. These projects already have shown a very clear usage in production, and we already see diversity when it comes to contributorship and adopter base. And lastly, we have graduated projects. And these projects are very deeply rooted within the industry, and they have a very clear roadmap, very diverse community, and unbiased contributions when it comes to the development of the functionalities for the tool. Now, within the CNCF now, we have 95 projects which are in sandbox, 37 are in incubation, and 20 of them are graduated. We will actually see this number changing quite soon because we have around 30 projects which are undergoing moving levels processes. Another thing I would like to highlight on this graph, you can see a very faint line, gray over there. Now, these are the archive projects, and currently when we have 2 archive projects. This is not a stage of a project that we talked enough. Sometimes a project gathers momentum at one particular time, however, that momentum disperses. It is only natural for us as a community to actually get the lesson learned and move our efforts towards either new projects or existing projects. Now, the community around Kubernetes was not always as flourishing, but more importantly, it was not always as engaging. The picture at the beginning was a bit different. Kubernetes is known for its ability to provision the environment for application execution while shrinking its footprint in the cluster. However, to reach the state of the art, multiple challenges required solutionizing, such as support for different networking and hardware systems. And this prompted the appearance of 2 interfaces within the cloud-native landscape, container network interface and container runtime interface. CNI was introduced under the CNCF umbrella in 2017, whilst the CRI was introducing Kubernetes 1.5 in its alpha release. Now, I would like to focus on these 2 interfaces in a bit more details because it will showcase the interoperability model within our landscape. Interoperability in a nutshell is us embracing multiple solutions for the same problem space. Let's focus on networking first. Now, exploring the networking fabric within the Kubernetes cluster is quite a challenging task. Kubernetes is known for its ability to schedule workloads on a distributed amount of machines while preserving the connectivity and reachability to these workloads. As such, the network topology is highly assertive, and it gravitates towards the idea that every single pod has a unique IP. Now, this network topology removes the need for dynamic port allocation, but it brings into light new challenges, such as how different pods, services, and users are able to access our application. Now, to fulfill this particular principle, that we have connectivity and reachability, and the pod has a unique IP across a distributed amount of machines, we had to introduce inclusivity for different networking systems. And this is where the CNI was introduced, or Container Network Interface, that concerns itself with the connectivity of pods and removal of resources when the pod is not going to be there anymore. As such, the CNI pretty much has two operations, addition and deletion. It will make sure to add an IP for the container when it spawns up, and it will make sure to remove any resources when the container is not there anymore. Now, looking within our ecosystem, networking is very well represented by tools such as Flannel, Calico, and Cilium. Many more. This is not an exhaustive list, but we already can see interoperability happening, multiple solutions for the same problem. Now, just for a simple network overlay, it is recommended to use Flannel, which is known for its simplicity to just be installed in a cluster with one command. If you want to have a more fine-grained access control to your services within the cluster, you would use a tool such as Calico, because in addition to the network overlay, it comes with a network policy enforcer. And if you care about security, you might use a tool such as Cilium that allows you the transparency at the network and application layer. Let's look at runtime next. Now, the story here is a bit different. Because at the beginning, the runtime capabilities for Kubernetes were provisioned by Docker and Rocket. Now, runtime is a component that intercepts call from the kubelet, and it will make sure to create the containers with the right specifications on the machine. Now, the logic for runtime at the beginning were very deeply integrated within the Kubernetes source code, and this presented two challenges. The first one being a very low velocity rate for new functionalities. That means that if I add a new feature, it will be released with the Kubernetes binaries, and this is a very lengthy process. The second challenge is that we're going to have a very high-level entry bar for new runtime providers. As a runtime provider, you have to have a very in-depth knowledge of Kubernetes source code to be able to release your product. This is not sustainable to move forward, and it was clear that we need a runtime interface to be introduced. As such, CRI appeared, and it provides an abstraction layer for the integration of runtime within a cluster, from which Docker and Rocket would be just some of the provided runtimes. Again, looking into our ecosystem, we have a plethora of tools focusing on this domain, from which we have Containerd and CRI-O being the most widely used tools, mainly because of their open source nature. It is worth to mention that Containerd currently is a graduated CNCF project, and CRI-O is an incubating stage at the moment. Now, it is only natural to allow vendors to use their own APIs or their own runtimes to create workloads on their own machines. As such, Google has its own runtime, which is called gvisor, and AWS has Firecracker. Now, networking and runtime, they were essential to increase the adoption rate for Kubernetes. And more importantly, we already see this interoperability built up within the ecosystem. From now on, the community concerns itself more and more with the extensibility of Kubernetes rather than settling down to very specific tooling. And we can see that by the appearance of a new wave of interfaces, such as Service Mesh Interface, Container Storage Interface, and Cluster API. And I would like to go quickly through them as well. The Service Mesh Interface was introduced in KubeCon Barcelona in 2019, and it democratizes the way we can introduce service mesh capabilities within the cluster. Now, for anyone new to Service Mesh, this is a dedicated infrastructure layer that concerns itself with traffic sent across different services, but in addition to that, it provides telemetry data. Now, we have tools such as Linkerd, Istio, HashiCorp Console, and many more integrating with SMI. Worth to mention that Linkerd currently is a graduated CNCF project. Istio is in incubation. However, it is undergoing the graduation process, so hopefully we'll have a vote on it very soon. Next, let's look into the storage. The story here is very similar to runtime, meaning that the logic for storage component was very deeply ingrained within the Kubernetes source code. And we had the same two challenges, very low velocity rate for new functionalities and a very high level entry bar for new storage providers. Again, it was clear that we need to introduce an interface to be able to consume storage outside of the cluster. As such, CSI was introduced in Kubernetes 1.9 in its alpha release, and it moved to GA in 1.13. This is one of the most widely developed area within the landscape. We have more than 60 providers integrating with CSI, from which we have Rook, Ceph, OpenEBS, and many more. Rook currently is a graduated project, and OpenEBS is a sandbox CNCF project. And lastly, we have Cluster API. Now, Cluster API takes the idea of interfaces a further step. Because when we talked about networking, runtime, service mesh and storage, all of these are actually directly impacting the application. All of it is within the cluster. Cluster API takes the idea of interfaces to the cluster itself, how you can deploy your cluster anywhere in the same manner. As such, Cluster API integrates with big cloud providers such as GCP, Azure, and AWS. You can provision your infrastructure to bare metal in a similar way with a provider such as Tinkerbell, or you can even deploy it in China. And if you had to deploy your infrastructure to China, you would know it's quite a challenging task. With Cluster API, you have that standardized. Another initiative I would like to highlight is observability, because here we again have standardization happening at the instrumentation layer. Now, as a developer, you always want to have that visibility and transparency across your application and the entire stack. As such, we want to simplify instrumentation while lowering the cost for data aggregation. And we have two tools in this space as well, OpenTelemetry and OpenMetrics, both of which are incubating CNCF projects, and they focus on aggregating telemetry data at scale. And the last initiative I would like to mention when it comes to standardization is application deployment, how we can simplify the interaction with our clusters, but at the same time enriching the overall end-user experience. Here we have tools such as kubevela, Crossplane, and Backstage coming into the picture. With kubevela, you'd be able to deploy your application just specifying one manifest file, completely abstracting the platform underneath. Crossplane, on the other side, is focused on extending the Kubernetes API and makes the best use of CRDs, of custom resource definition. And lastly, we have Backstage, that is pretty much a tool to provision these developer portals, completely abstracting the terminals and allowing the user to interact through a UI. Now, thus far, we can see that we have a very vast ecosystem. Thousands of tools are part of our CNCF ecosystem. Now, whilst the technology is the gravitational point of open source, none of it would be possible without a community around it. From the beginning, the Kubernetes community operates on the principle that inclusive is better than exclusive. We build, scale, and retain contributor communities through open governance, transparency, and a diligent code of conduct. This is what pushes innovation forward and invites everyone to contribute. Now, if you'd like to be involved or contribute right now, you can do so. If you go to contribute.cncf.io, you'll be able to see a list of all of the projects that we currently have and ways for you to contribute straight away. However, contributions are not only limited to code. You can actually get involved in providing feedback about your experience of using open source. And you can do so by joining one of our micro-communities. We call them tags, or technical advisory groups. The tags themselves are pretty much formed of specialized or experts within the industry that focus on a very niche area. As such, we have a tag for networking, security, observability, many more, but more recently we have the tag environmental sustainability. This particular group aims to put innovation or sustainability on the agenda for every single open source project. Now, if you join one of these tags, you'll be able to contribute straight away, again, by providing your feedback. You can be involved in creating the next white paper or provide some community guidelines on using a specific tool or domain. Again, all of the information about the tags is publicly available. You can see it on GitHub, where you can actually explore the charter, the governance. All of the meetings are available, recordings publicly available. So you are able to get involved straight away. There's no gatekeeping when it comes to actually being an active member of the community. Another thing that I would like to mention for us as a community is that we need to direct our efforts into creating the space for the next generation of cloud-native practitioners to operate in. For that, we need to lead through a culture of education and upskilling. We need to scale at the same pace as a community with the technology evolution. Now, when it comes to the culture of education, currently we have a plethora of certifications around, from which we have 3 professional level certifications: CKAD, CKA, and CKS, or pretty much Certified Kubernetes Application Developer, Administrator, and Security Specialist. Now, as I mentioned, all of these certifications are professional level, which means you need hands-on experience of Kubernetes in production to be able to pass them. The exam itself is a terminal, and you interacting with the cluster straight away to get the results for the questions. And we had some feedback from the community around those certifications. The main feedback was it was not very inclusive towards the beginner audience of the community. We heard this feedback, and we have created the KCNA, or Kubernetes and Cloud Native Associate exam. This is a multiple choice entry-level examination that allows everyone new to Cloud Native, or anyone looking to make a career change, an opportunity to demonstrate their passion and understanding of Cloud Native. Now, to follow the same example, we have 2 new associate certifications coming on the way. One of them focusing on the security, and the other one focusing on GitOps practices. And we can see, well, actually, hopefully, they're going to be launched in the next couple of weeks. And as part of the same mission of lowering the bar to entry for new people in the community, I have created the Cloud Native Fundamentals course, which you can find on Udacity. This is a free course that takes anyone with some programming experience through the journey of understanding what is a container, how you can use Kubernetes, and more importantly, how you can learn and apply Cloud Native principles in production efficiently. Now, as a community, we have developed software that changed industries and entire sectors out there. We need to continually create this welcoming and respectful environment where new ideas and feedback is valued. But more importantly, we need to further diversify our executive leadership, governing and technical committees, and advisory boards. As such, I would like to invite everyone and encourage everyone to continue building a diverse community. We need to create the space for the next generation of open source leaders to operate in. And this leads me to the perspective. How exactly Cloud Native impacted different communities out there, such as vendors, end users, and the overall open source community? Now, when we're looking into the vendors, Cloud Native translates into innovation. As a vendor, you do not have to reinvent the wheel anymore. You have the interfaces already available. As such, as a vendor, you can reuse these interfaces and provide value to your customers straight away. Now, when we look into the adopter community, Cloud Native translates into extensibility. It was never as easy as it is today to benchmark different tools with the same functionality. As an end user, you can choose the right tool for your stack with minimal compromises. And when we look into the community, Cloud Native translates into inclusivity and diversity. We always need to strive and create this inclusive environment for feedback and ideas to be valued. But we still need to do some work. We still have to work on diversifying our executive leadership across the board. And all of this has been possible because Cloud Native is a center of innovation that is driven by a sustainable community. But more importantly, it builds technology focusing on the interoperability principle, where we embrace multiple solutions for the same problem space. Now, without saying, we are hiring. If you'd be interested in working at Apple, be it in Europe or US, please visit jobs@apple.com, where you'll be able to find some of the latest roles and openings. If you'd be curious to learn about my latest pursuits in technology, follow me on the Medium account. I'm writing about my latest findings, usually there, trying to revive the space. And if you have any questions in regards to today's talk, I'm more than happy to answer them, or you can reach to me on social media such as Twitter and LinkedIn. As well, this is the QR code towards the Cloud Native Fundamentals course, if you'd be curious in taking it. This is Katie Gamanji, and I look forward to seeing how you can shape the Cloud Native ecosystem. Thank you, and enjoy the rest of the conference. Oh, we have the MC running.
Oh, hello, sorry. Sorry, Katie, you were quicker than I expected. Did we have any questions on the Slido? We do. How do you see Kate, am I saying that right?
Mm-hmm.
Kate,
yeah.
applied in telecommunications where long-lived TCP sessions have to survive pods being created and destroyed while scaling a service?
That's a very good question. The only thing I can say here is that we have a group in the end user community that is just focused on telco applications. And here where you'll be able to find some of the best standards. I don't have them on top of my head, but I can point you in the right direction and to the right people. So yeah, reach out to me.
Any more questions? No? Katie, you were super efficient with your time. Oh, we've got one. Where to go with serverless architecture or when with Kubernetes?
That's a million-dollar question, I would say. When it comes to serverless, it is able to solve a lot of problems for us. I think if you're using public cloud, Kubernetes, or serverless, you need to really understand your use case. First of all, do you actually need the cloud and why? What is your mission? Second, what is your budget? And third, do you have enough resources? Do you have a team that supports that mission? I think answering these 3 questions will help you to decide if you go with Kubernetes or serverless, because Kubernetes solves a lot of problems for us, but it's still a very heavy lifting tool as well. And it requires a lot of effort to maintain it. Serverless, on the other side, can get your application up and running within a day. You can have the pipeline ready, an application running straight away. And it solves the problem very quickly. But at that stage, you're going to deal with things like scalability and perhaps latency if you're using serverless on kickoff, pretty much. So I think it really depends on your use case. There is no right answer. It's going to be driven by your application and your use case.
Any more? No, there's that a 0? Oh, behind me, he said. Oh, there's loads. Fabulous. Okay, top 1. What tool would you recommend for cluster security monitoring?
Again, this depends a lot on what you have within your cluster. We have a plethora of tools focusing on the security aspect only. This area is very well led by Tag Security, and they have a lot of white papers. They even focus on the supply chain security for your cluster. Now, security monitoring. Again, it depends if you use a third-party cloud, for example, because they're going to have all of the security available for you, or you can use one of the open source tooling. Depends on use case here a lot. I cannot really recall one. I think that's going to be unfair.
Okay, next one is from Jacob. Congratulations on not being anonymous. How do you see secondary networking in Kubernetes? Any thoughts on network service mesh?
Secondary networking in Kubernetes, any thoughts on network service mesh? I actually didn't have a chance to use it myself, so unfortunately don't have direct feedback for that. But I'm curious to see what are your thoughts on it, so reach out to me after.
Can you share a good example of Kubernetes being a good use case and a bad one?
Kubernetes being a good use case. I think we have hundreds of organizations that use Kubernetes in production very successfully. I think the only bad example of Kubernetes, again, if you have your mission statement, you want to modernize your applications, for example, you have enough resources and you have a good team to maintain your clusters. Supposedly, you have a very good use case for Kubernetes. I think the best scenarios are happening when you have something going down or you have a failure within your cluster. I think this is where we deal with the fact that disaster recovery is very difficult with Kubernetes, and you really need to be prepared for that. So, yeah, again, I would say bad scenarios, that's when Kubernetes is perhaps not the best use case.
Okay, we've got another one. Are there any other interfaces you might anticipate emerging?
Sorry, can you repeat that? Which one was it?
Sorry?
Which question was this one?
It was, are there any other interfaces you might anticipate emerging?
Yes. So here we might see interfaces. So currently we have a developing area when it comes to artificial intelligence tooling. So we might see something standardization happening there. We might see something when it comes to edge devices as well. So all of these areas currently are in conversations between different working groups and different SIGs, and this is a very good opportunity for you to get involved. But yes, there are definitely going to be more standardization coming on the way. I think this is going to be led by the community. If there is interest and there is necessity for having this unified manner on deploying the tooling, that interface is going to be created. So definitely driven by the community. We cannot say, create this interface. People don't use it. We need to see that interest from the community first.
Do you think we will use AI-powered K8 ops solutions in the future? Are there any projects using AI already?
The answer is perhaps. We already have within the cloud-native space, we have tools focusing on on using ChatGPT capabilities. One of the tools that I think opened a request for Sandbox is, I forgot the name, but pretty much what the tool does is uses ChatGPT to see or to provide you solutions for the error you see in your terminal. Based on that, you'll be able to debug and troubleshoot way much quicker. So we already see this kind of tooling appearing in the space. Very emerging. Again, there is even an issue opened 2 days ago around creation of a new tag focusing on AI. So when it comes to AI, very emerging space in cloud native. Lots of things happening there.
Suggestions on tools for visualizing K8 telemetry?
Good question as well. This again is going to be very heavily driven by the tooling you already use, because perhaps you have a cloud vendor that already provides this telemetry data for you. Grafana Prometheus is a combination made in heaven, always a good combination to visualize what's going on within your cluster. Now there are dashboards that focus, for example, on enhancing or simplifying the SRE perspective and actually troubleshooting and debugging. We have tools focusing on that. We had another tool which was accepted to Sandbox. Literally yesterday, we accepted the tool in Sandbox, which focusing on unifying or providing a new dashboard solution, because we know the Kubernetes dashboard had some mixed feedback. So again, this is something that we kind of developing. There is an appetite. The straight answer, I think the short answer is going to be Grafana and Prometheus. That's a combination.
I think that's all the questions, Katie.
Awesome, thank you.
Huge round of applause for Katie for answering all your questions.